Hello. Let's start. Hi, everyone. Thank you for attending this workshop at Coalesce. Thank you to everyone who's online participating in the Slack. We're really excited for all of you to be here. My name is Amos Buddy. I am the Director of Services Partnerships at DBT Labs, and I'm emceeing this workshop session. I'm excited to introduce the workshop title is Detecting Data Anomalies via an Inspection Layer, and I have with me two great speakers, Neil Acord, Technical Architect at Red Pill Analytics, and John Rensberger, a consultant at Red Pill Analytics. I just wanted to quickly note that all of the chat conversation is going to be happening in the DBT community Slack. The channel name is Coalesce Detecting Data Anomalies, and this gives everyone a chance to participate in the conversation, and the speakers here can also continue the conversation with folks in the Slack channel after the session is over. Great. Without further ado, let me introduce Neil and John. Thank you very much.
Well, hello, everyone. It's good to be out from my home office, out in rubbing elbows with real people. And today we're going to be talking about detecting data anomalies via an inspection layer. And I am Neil Acord. I'm a technical architect at Red Pill. And one of the things I've spent a lot of time doing in the past couple of years is helping people migrate from on-premise to the cloud with an emphasis on DBT and Snowflake. And a lot of the times there's an Oracle on-premise component to that. So, John, you want to introduce yourself real quick?
Yep, my name is John Rensberger, and I've been doing data for about 10 years, a lot of it in the analytics space, but also time doing master data management, looking at problematic data, trying to identify problematic data, and this has really aligned with all of that I've been a part of. So, back to you.
I just want to say real quick, I'm glad to see such a good turnout in the room at the end of a day. Thanks for saving some gas for us on the end of a session-heavy day. And also thank you to those who are joining virtually. And all direct questions to the Slack channel, and then we will start to pin those and to answer those, if not in the session, within the hour after the session. So, what are we here to talk about? We're going to talk about the problem solution that we ran into at a couple of clients. We'll show you an example of these data issues, which will not surprise you. You've all run across them. A high-level review of our implementation of this inspection layer, and tell you just a little bit about the sample data set that we use from healthdata.gov, right? Got a link to it here in a second. And then John's going to walk you through the implementation details. In the first part, I'll just kind of set it up for you. How we set up the project, normal DBT type stuff, and then John's going to walk you through what we did to add this inspection layer. So as expect the unexpected, you know, in our solution you will see, or in our use case, the customer is, we are using customer provided data. So think of thousands of customer provided files in our favorite format, CSV. So, and that's being served up, and we'll see here in a picture of how the data flows through. So the solution presented itself through customer provided data. You know, they're not the most technical of folks. They're doing the best they can with these CSV files, and we're going to walk through some of the challenges that we were faced with and what we did with this inspection layer. So we'll talk a little bit about normal DBT test, and John will run through some scenarios, right, of like going, hey, what if we test after each layer? What if we test at the very end? What are the various ways that we can test, and what we did with that with the inspection layers? But overall, the stakeholders, let's say that this company was providing a product. The clients give the data, and then there's benchmarks. And they want to see that data quickly. We just gave you the files, why can't we see our data? So out of thousands of files, there's usually a small percentage of the client-provided files that have the problems. So how do we quickly move the good data through, hold, the bad data back, quickly respond to that, and even get that loaded quickly. That's kind of like the tee up for it. Overall, the stakeholders don't want a few problems to hold the big show up, and also to quickly respond to the issues that we need to take care of in these client-provided files. Well, in client-provided files, some of the examples is CSV files. So, you know, the standard format, we've talked about it many times with the client. The column name should be this. You know, it is in_person, not in space person, not in camel case person. It's in_person, but it happens, right? Formatting. Phone number is not formatted. It's a date, not a date timestamp, things like that. Normal spelling errors. It's not supposed to be null and it's null. Duplicate data. Incorrect dates. And with that inaccurate data, you know, me and John were talking today, is like, what's a really quick example of that? Okay, I am going to a medical office for my first time appointment, and the data starts to come through, and this person is 200 years old. That is inaccurate data. So that's kind of like some of the examples of the things that is no surprise that can happen in client-provided data. So we're not going to show you our client's data. So what we did is we kind of went and found a very simple data set. It's basically school district data for learning modalities that kind of came about from the pandemic and the lockdown. And what we'll see is that, you know, there's in-person modality. I'm actually at the facility or the school. Or I'm hybrid, which means sometimes I'm at home and sometimes I'm here, and then remote. Very simple data set to demonstrate the inspection layer so that you're not saying, what does that data mean? It's school district data with, you know, hey, or what's the count of students in person, hybrid, or remote? So in our case, yes, SFTP server is still out there and it lives and it's doing well. And so that was just an easy way for this company to give their clients an easy way to upload files. The files were kind of like uploaded on a schedule by Fivetran to Snowflake, and then the DBT models did their transformations on it from there. Just an example of what this data set looks like. It's really tiny, but we have a link to the slides, and the link to the repo for this is also pinned in our Slack channel. So you can look at all the examples of the code that we're going to be showing today. So, real quick, for the DBT project setup, we are going to be starting at 1, staging models. It's just like we're just going to source things, and we're going to do some light touches, intermediate models, and marts. So staging, referencing the source of intermediate models and marks. This is just typical standard best practice. We always start from like DBT's best practice, like how we set our project up, we set ours up the same way. For the staging model, just light touches. For here, you know, we've kind of taken some names that say _file. We say, you know, that's actually the Fivetran file. So we've maybe done some aliases, we've changed the dates, but we have made very light touches in these staging models. Just a preview of the data. Now, what we realized when we said, okay, well, let's take it away from the client. Let's use some sample data. We're like going, we don't have a date dimension. Because, you know, you just kind of get used to that date dimension always being around, but, you know, sometimes you got to ask yourself, how did we ever get that thing? It's been around forever. We used a DBT date package, and you can see here, John, I don't remember who was it. Was it Collogic?
I'm not sure who made it.
Collogica.
Yeah.
But here you can see how we just took one package. We added it to the packages file, set the variables as described up in the project file, which is basically what's our time zone. I want the date dimension to start here, and I want it to end there. And then like with just a few, and you can see there, there's the call to the package in the model. And in just a matter of minutes, we have a fully blown date dimension with 36 plus attributes, and we were able to get to the pieces and parts of the date that we needed. Just, that's a date dimension. Okay. For the intermediate model, we have started implementing getting away from surrogate keys. Surrogate keys across environments absolutely are a pain, especially when things get out of sync. We have started to use, encourage our customers to use natural keys, and then we will take one or more of these natural keys and do a hash on it, an MD5 here. So that is our primary key. And this is just a placeholder for that intermediate logic, the transformation logic, that is going to be the main rules. And this is all just to demonstrate that to start with, we have staging models, some intermediate models with some transformation logic. And here we've just kind of like taken a simple sum with a group by, and that's kind of like our analysis model. Now what John is going to be walking you through here is talk about some of the test challenges that we had, and then walk into the inspection layer and the slight tweak that we did to DBT tests to come up with the inspection layer.
Clicker, please. All right. Thanks, Neil. Yeah, so at this point, you'd probably say to yourself, I've got a project, I've got data, I can test it. That's what DBT offers, right? The nice thing about testing is the framework, easy to set up, like we've done here with our YAML file. We can put in, we've added that row key, we can do a unique test on, make sure it's not null. But as we do that, what'll happen is, well, we'll actually probably have a problem that comes up. We'll even add, I guess in this case, a singular test as well. In this case, we added one about, let's say our district IDs do have some alphanumeric values, not just numeric values, something that the YAML can't do, and we'll implement it and put it in there. And there could be more. So what it would end up looking like is our lineage graph would come up looking like this. We've got everything we talked about, how it flows through the steps, and then we'll go ahead and build it. When we build it, we'll be like, it's going good, don't do it. Oh, there's a failure. What happens there? Everything after that gets skipped. What do you do then? How do you address it? Where's your problem? In this case, we're going to see that all sorts of things didn't run afterwards. We'll have problems in the data, and everything downstream didn't get processed. We won't be able to show it. Another scenario that could happen, if you stage this another way, is we could have an assertion that passes on the source, but fails in the intermediate layer. There, we'll make it through a long way, but we'll still not load the data, not be able to look at it in an analysis. Another way, we could just say, you know what, we just need to see the data. Let's just run it. We know there's some problems, but that really can interrupt your quality of your dashboards, right? So you want to go over and say, what can I do to pull this out, as Neil was alluding to. So to do that, we could also add some more tests on the end. We could just let it flow through, as I mentioned. And here I'll show, if we show tests at the end, as we showed in that example, the test will actually fail. I'm sorry, this isn't lining up. When we submitted it, it did. But here they'll fail, and we'll be like, yeah, we got bad data. What do we do? Sorry, it's in there. We'll go fix it real quick, right? Burn my weekend spending time fixing it. So that's not what we want to do. So what this would end up looking like in a dashboard, it might look like this. And these are purely demonstrative purposes, right? We didn't do anything crazy with the data. And we're making some assumptions just to demonstrate what would happen. So we've got, in this heat map, we can see all sorts of days of the week in the middle of what's coming up. We can see in the top right, there are null values appearing where there shouldn't be. There are also invalid modalities. Some people fat-fingered, they've got hybrid instead of hybrid. They've spelled things wrong. It doesn't look good if you're presenting to a school district or representing something in the federal government. You're not going to want to show that. So our answer to this was add an inspection layer. And this was purely DB2 driven. There's not a whole lot of secret sauce to it. It's just really staging the project to do this in a certain step through the DAG. So we defined some DBT models, actually, that can just be what we did for our tests. We set them up to find those anomalies, identify them. We then later reference those models so that they will be used, built in the correct order, and we tell the DAG to exclude the data that was detected, and then we provide a way from those results to feed back to people, these were the rows that had problems, everything else that was fine is going to show up. So for our example, we made some simple expectations, like weeks should begin on Sundays, there shouldn't be null values, we shouldn't have duplicates, we want the modalities to be those 3 results that Neil said, in-person, remote, hybrid, and the district identifier should always be a number. So to set this up, all that we did was created in our project an inspection folder in the models directory, created our models that were our tests, and then we actually defined tests that are one-to-one to those models that just reference the inspection model. They don't do anything else, they just select star from the inspection model, and that's all that we really have, so we can run a test. We also set those tests to just warn, because we don't need it to necessarily say that the project failed, we just want to pull up that there was a problem. So, this is an example of what one of the tests would look like. And here we've got those modalities of expecting it to be in-person, hybrid, remote. Again, we can't really leverage the tests in the YAML to do the same accepted values because of how it detects everything. So we've implemented the same thing. We put in, here's what row, here's the file that referenced it, and here's the problem, and write that into a table. And this is an example of what that would look like. So in here we can see that we've got values that are not in person, or we've got someone hit caps lock first and typed in person, so it's not following the format that we want. I said other typos like high bird and other typos that went on, so that's something that happened. Another example of something that we set up was that week starting on a Sunday. We utilized our date dimension that we built to go back. A column that we had provided in that was the week starts on this date, and we just identify everywhere that those did not happen. And then when that was the case, in there, we get a result like this that actually says, here's the value that I was given, and on the right side you can see, well, you can't see, it's so small, but if you look in our deck, it says, this is the date that we expected. And a third example was finding null columns. This we did some fancier Jinja, it's really not that fancy, but a for loop to go through, identify all the columns, look for any that are null, and we'll, from that, get any column that comes up with a null value will get reported. This was the record. Once we have that, we create a main inspection model. Shout out to dbt utils, a very common package. We're using the union relations method, or macro, so we're calling all the models we created. You could optionally, build one inspection model with a whole bunch of unions within it, so you don't do this, but personally, I think it's nice to get a one-to-one assertion as to what the problem is without having to investigate too much more. So that's why we do it that way. And once we have that inspection model, our intermediate model references this inspection, and we just say, take all the rows where they don't exist in that main model. From there, we get a nice, concise, everything that's passed didn't get flagged in those models, makes it through, and they'll load and do what we want. And then in turn, our assertions that I mentioned were set to warn, where it's one-to-one with just this simple call that inspection model, will then give us feedback like this, where we've got warning, we've seen this test failed, here's the number of records, and your ops team can start to triage from there of what would come out. In the lineage graph, it really looks like this, where we can see now there's that union model in the middle that has all the inspection going on, our intermediate from there. You can see the assertions in there. I know it's small in here, so try to check it out, or if you look at our project, you can see it more. And what does this look like with it actually happening? So in our tables that get built out, here we can see this was the raw file as we were building it. We can see the problems here, and we can go back and correlate that specific test, where that went on, we can find the problem, and in this case, you would triage to that district to fix their file. I'll go through a bunch of these, but more things, date's not on a Sunday. Got the same sort of feedback, here's your correct week. Another example of, there's a null value, the city is missing, get that same result back out, city's gone. Another one, this is one file that has a whole bunch of problems. Not sure what happened when they entered this, but they even missed their district ID one time. But our trustee test will detect those, find the nulls, pull out the rows. One more, that's the hybrid example, and also there were some inconsistencies with the city. That was another rule we set up by the stakeholders wanting that, so it detected those as well. Last one more nulls. So I guess I have one more yet, more problems. So there, you can do a lot of these, right? But all sorts of things that go on and how you would detect it. So this is a side-by-side, what will happen if you run with the inspection. Now we know we're going to be missing some data, right? The full count may not have everything that you're expecting because the rows that were bad aren't there. But in our stakeholders' eyes, that's better than no data, right? We'd rather see what we do have and take out and give us some clean data. We also have, we can see now that all of our Sundays are correct. Those are removed. On the right, we see it's consistent. We only get one set of time that shows everything. We did put together in this, just using Snowsight, kind of a high level, and you could build this as you want, a dashboard that shows you a summary of which files had problems. So we can see the top one, there were 39 problems identified in there, and give a feedback so you could choose to triage it however you'd like. If you want to assign certain tests to certain groups, or maybe you've got your districts broken up by different support teams, something like that, however you would want to go about it. We can provide, kind of what we did. There's not really any fanciness to this, it's mostly Snowsight, but something you can do. And then in our method, using Fivetran and CSVs, the method to resolve would be have them resubmit their files. Fivetran does an update to the rows that were there already, and they'll get reprocessed. Depending on your use case of if it's a web service, maybe they'll come in again. Using a lake, maybe you'll do something to clean it up in your lake. That's not really being prescribed here. It's dependent on your use case. But there's a method that, in our case, how we're demonstrating it, we just loaded the fixed files, and everything flowed through with our next DBT build. What we saw in our dashboard then is there's no more problems. We just get this nice clean, nothing else in there. So, to summarize, the inspection layer identifies any data that shouldn't be there, quarantines the data that was identified to not be loaded, and if something is loaded, it can be resubmitted, as I mentioned, and processed again. And that will hopefully minimize your downtime for what was loaded, keep you from having to spend a whole bunch of time on a weekend letting one problem hold everything else up. So, at this point, that's all we have. Any questions? Anything, stuff coming up? Okay.
So we have one online, John. I'll read it to you, and we've talked about this. What are we talking about? Are we talking about full-blown data observability, or we're building versus buying? So there are some vendors in the market focusing on detecting and acting on anomalies. How do you see the buy versus build for this challenge in data items?
Can you repeat it one more time?
Basically, the buy versus build. Why would you do this?
Yes, sure. Yeah, so we're really not really coining it, but you would call this your observability light, or your I'm a startup, I don't have any money, I can't buy something fancy. I'd like all the dashboards, I'd like to get the nice feedback of what values I have. This is more, let's get started. Let's not, as DBT has done for many people, let's remove barriers to entry. Let's get something that gets you started. It's not meant to be a replacement for observability. That's very powerful, something that you probably want to get into, but it gets you started, right? It keeps you from getting into it. So that's our take on it.
Another question. How are you implementing severity with the workflows? Say, for example, 50 null entries for a column that should be null versus simple misspelling. How do we come up with our test, I guess?
Yeah, I mean, there are many ways to do that, I would say. In our case, we didn't do anything around it. I think we could probably come back and describe some ways in Slack to give you a cleaner example. There would definitely be ways to do it, though. So we can circle back on that one.
And one other question, do you also catch cases where the number of rows per category are lower or higher than usual? And I think that's how do we come up with our test? And I think the answer there, right, is like we came up with a test because that was the issue that we had that was important.
Yep.
And there's a couple of other questions that are kind of similar online, and that is, the number one problem in our implementation was given 1,000 different kinds of clients given files, a few were holding us up. So our implementation was really focused in on how do I address those problems but let things load. You can come up with as many tests and get as complicated with these tests as you want to.
Yep, I would certainly, and clients that we've done this, it's iterative, right? You don't fix everything in one go. You start finding things that would come up and you keep building it out, much like you would any of your tests in your data. So yeah, we can circle back on any more. Are there any in the room that anyone want to ask? All right, well, I think we can give you some time back, get ready for you to find some food, and yeah, Amos.
Thank you, John. Thank you, Neil, for a really great presentation. And yeah, that wraps up the day. Thank you so much for another wonderful day. We will see you all at Coalesce tomorrow. And have a great night. Bye.